is Dave Chappelle, and today we're going to be teaching about electromagnetism. Ooh. All right, so what is induction? Well, I'll be happy to explain it to you. All right, induction is how a magnetic flux changes and how that change produces a certain EMF. So let's get to the fundamentals. So a magnetic flux is a magnetic field in the area that passes through. The flux is defined by phi, which is equal to the field times the area times the cosine of the angle. And we have the EMF. And the EMF is, of course, produced by the magnetic flux. And that is an electromotive force, which is equal to the number of turns of a coil times the change in magnetic flux with respect to time. So we're going to go over here. All right, so you have your Helmholtz coil A, and this has a certain magnetic field. It's a certain distance away from Helmholtz coil B. The magnetic field is going to travel, and it's going to produce some EMF depending on the area and the distance from the first coil. Seen in this equation, this is the distance, the magnetic field, the area, and the angle. So you can imagine that this is, I don't know what this is. This piece of paper, you have the sun coming in. These are my fingers are sun rays coming in and hitting the paper. This is going to produce some shadow, but if you turn the paper, it's not going to produce any shadow at all. And we're going to see in the lab that once you rotate this a certain angle, it's not going to produce any EMF, which means the magnetic field is blocked and can't travel. So we're gonna get on. Physics is so hard.
I can explain physics to you. Okay, today we will be doing a lab experiment, and the purpose of it is to examine Faraday's law of induction, which states that a changing magnetic flux produces an EMF and electric current in a conductor. So what we will be doing is running a constant current through coil 1, which will produce an induced EMF in coil 2. And factors that can change the EMF would be a change in distance, a change in angle, or a change in frequency. So as we move coil 2 from 0 degrees to 90 degrees, our EMF will get closer to 0. And as we go from 90 degrees to 180, the EMF will increase again. Okay, so as we were doing our experiment, we entered our values of EMF and the angles we used. And as you can see in the graph, the EMF decreased as we got closer to 90, and it went back up and increased again as we went from 90 to 180. Do you understand now, Chris?
I finally get physics.